Nerding and Hoarding. Quick and dirty DIY electronics.
Alright, welcome people. Today it is improvisation time. How do you spell that? Improv. So, improve. Does that say improve or improv? I have no idea. So we just skip that. Here we have some coffee stained pen. Oh, this is actually my rent. Alright, so yes. So maybe you heard about a little something called a stable multivibrator. Anyway, if you haven't, it's a real basic and funny thing. It goes like this. There is a cross right here, and from this cross it goes like that. It goes like that to a NPN transistor and mirrored symmetry on the other side goes like that. Here we have one capacitor, here we have another capacitor, and here we have one resistor, and one resistor going up to a voltage source. So there you go. And this goes to ground like this. So and here we have positive voltage. Yes. So how many components is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can also right here add an output jack. But unfortunately, what happened now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, so we have 11. Well, yeah, let's do a little thing like... No, that's not going to fly actually. So how do we do this? Yes, we do like this. Oh, I am so smart. Like that. So the thing about a stable multivibrator is that you can make it work sort of good, and you can make it work sort of not good. And when I mean good, then it is producing a wave that is almost a square wave. And that is if you make it very symmetrical and within the linear part of it. If we are sort of putting ourselves outside of that area, we can get very strange behaviors. We can get, first of all, we can get sort of so we like things, but we can also get sort of quite unexpected behaviors like that. So with this in mind, I'm also quite interested today to do something which is having randomness, in the sense that resistors can be light dependent resistors. So it will act on the environment. So without any delay here, I just say, let's build this thing. Bam, there you go. And guess how we're gonna start? Well, the guessing is not so much about guessing, it's more like I will tell you. And it's like this. I will insert a thing called a solder iron into a thing called a wall socket, and then we will have to wait. So, and I will pause the waiting. Right here I am back, and if you wonder why does this guy talk about how many components there is, well, it's because I have this challenge right here. It's called 10 or less synth modules with few components, and it's a DIY challenge that you can join. And if you build or design something with 10 components or less, please send it to me and you will be part in a competition where you can win great prizes such as Vectros, 5x5 timers, and other cool DIYs and stuff. So, without any more babbling for my account, I will just sort of begin this exploration. So I'm putting the component on the drawing or the schematic. So, and here is because I'm not really sure what value I will be needing, and here I invented a new component called a double LDR, or the LDR potentiometer. Oh, like this, you see. Alright, this is so cool. Alright, now focus. I forgot that I needed two of them slightly larger, because if you improvise, you know, you still have to get into the area of frequencies that the human ear can actually hear. What was that? Right, there's nothing. Alright. So you can also make this in the low frequency oscillating spectrum, and then you can also add LED right here, but then our part count is too large unless you use a component called a resistor diode LED that you might invent. So here I invented the potentiometer, the light dependent potentiometer. So this is one component, otherwise this project will fail due to too many parts. Counting. If you want to add voltage control to this, you can do it by removing this from the support from the incoming voltage, the V plus, and put it to CV. But we're not doing that today. So you see we have sort of everything laid out beautifully right here. We need to know the pin out of the NPN. NPN means transistor, is also called BGT or just trans. I mean, you can call it whatever, you can call it Charlie or whatever. But look here, it's this one right here called 290. I just picked it at random. It's an NPN and it has pin out that is like this. If you look at it from above, like this, like so. Yeah, my camera is really bad, so don't mind that. But anyway, I will just sort of stretch out its legs into a nice shape like that. And we will see here, I look at the pin out and it says, what does it exactly say? I have to focus now. Collector. Okay, focus. By the way, this is collector, emitter, and base. And the first thing that I know is that this, at least this is the base. But the most important thing, which one is the cathode and which one? No, the collector. So please make me, so is it, yes, like this, C and E. If you want a pinout, you just look on the internet and you write the name of your component and you write the word pinout and then you search for an image and then you got it. So that means that we will put this one like this, and the other one we will make sure that it is the same orientation. Oh man, this camera is really bad. Again, the only thing that we do is bend the middle leg to the right instead of to the left, like that. And as I might have told you earlier, if you have been in this channel before, is that there are many ways to actually do a circuit. We can do it in free basing in the air, so to speak. We just solder one thing to the other. That can get a little bit complicated if we have too many components. We don't have so many components today, so we might not have to worry. But so what I'm planning to do now is to actually do it on the back of the panel board. And the panel is, if you have a eurorack thing, you have a front plates, so to speak, and there you put everything that needs to connect, or what's on connectors and such. And this one I will be putting the what's it called, the light dependence resistors on the front side like this, and everything else will be on the back. So just give me a drill, right? If you don't have a drill bit, you can always use just a nail like this. It's especially small drill bits, they often get destroyed. They break off. Yes, break off is a good word. Well, then you can use a nail just like this. And if you need a smaller hole, just use a smaller nail. And you can also take this, put it on something of metal and bang on it a little bit with a hammer. Then you get a more of a spoon-shaped drill bit. Oftentimes I see, if you look at a sort of assortment of drill bits, and often, you know, the smallest one are just not there because they got broken off quite early on in the process of using the things. So like this right here, you see how beautiful is that? It looks exactly like I wanted it. So what we do now is we draw this on here so we know what goes where. So plus voltage goes here, and here we need a little hole there, and here's a resistor, here's another resistor, little hole there. Oh no, we don't need the holes because we do everything on here and then just glue it together. Alright, so that will be right. So here we put a capacitor, bam, and then this goes in a cross like that, this goes in a cross like that, and yes, we have this goes up, this goes down to negative voltage, or just ground as we can also choose to call it. So now already this presents a little bit of a problem right here, because if I put this here it will just fall off, you know. Whoa! So we need a plan of action. So plan of action is exactly what? Good question. Well, plan of action is like this. Take a red wire first. Good. You need to like put your foot down right there and sort of show who is the boss of this particular build. So take a red wire, you see. Red means positive voltage, always in my builds. And also make sure that you know where to put your power header, pin header for inputting incoming voltage. And I think I will put it somewhere down here. So we need a little bit longer, so it needs to go from here and all the way up there. So, like this, right here. So now I just take one part at a time, and you know I'm doing this in order also for you to see what is the problems of doing it this way and what is the strengths of doing it this way. So you see it very straightforward and intuitive, but on the other hand it's sort of messy because you know there's nothing to hold things down. If you use another board like this with the holes in it, you know, you put the legs of a component through the holes and they will stay there. But on the other hand, then you have a panel and a PCB, and you need to attach those to each other and so on. There is and there are. So there is singularis, there are pluralis. Yes, because of my dyslexia I was forced to spend extra much time of learning language things. So therefore I know what is pluralis and what is singularis. Singularis is one thing, pluralis is several things. So there you go. Knowledge, unnecessary knowledge of today. Maybe that's something everyone knows. How should I know what everyone knows? I'm just one person, yeah. So if we should use this little drawing here, we could make a little scratch as we have completed something. Now we come to the part that will be saved just for a little bit, because I'm not exactly sure what capacitor I will be using, so we just leave that for a little bit and go on down to the transistors. So now it's getting a little bit like wobbly here, but I try to twist these around each other a couple of turns like that, and then I will try to solder that down. Yes, as you see, this is a method of doing this, and you see also that it might work if you have a very simple layout. And you might also understand that it is not so good if you have very many components, and especially if you have these things called integrated circuits that come in sort of bug-like packages, meaning that they have very many legs, which are very short and very hard to freebase solder onto. So you see these things are just sort of sliding around here. I'm not saying that's a bad thing, I'm just saying that is a thing that you need to take into consideration, because I'm not going to tell you, man, you should always use strip board, you should always use PCB, you should always use point to point. I'm just saying, you know, this is my experience of these things right here. Okay, so now we are going to make a crossing right here, like so. And as you might understand, they will be in contact with each other. So therefore I take one piece of hot shrink. I don't actually know what is its real name, but I will call it hot shrink. So you can think of Freud with some sexy leather boots on or something. I don't know what gets your fancy going, you know, but a hot shrink. So yeah, it's good enough. If you are worried that you are making a mess right here, then you can always put a hot shrink on the other one as well, but I will not do that because I'm so quick and dirty and poor, so I don't want to waste all my expensive hot shrink. I'm not saying it's expensive, I'm just saying that if you consider all of the components that I have bought, the combination of all of these values are very, the values. Isn't that fun to call something value when you actually mean price or cost? So, and as I realize, if you look here, everything is loose, so therefore I will use the hot glue gun. And it takes about 10 minutes to get it warm, or hot, so I will just put it in now, and when it's finished I will glue everything down to make sure that it stays down. So now I'm taking this one, okay, so this is down, this is down, this is down, this is down, and now I'm taking this and this. So first thing I do is take a wire and decide where do I want the output jack to go. So I want it to go right here, right there. So then I need wire from here to there. And this is a little bit too long, but you know, doesn't matter too much. And I take this very small capacitor. I'm not exactly sure about what would happen if you don't take a capacitor, but maybe the thing that you lead the signal to will interfere with the vibrations in this circuit. But you know, you can read that in the comments fields below, because hopefully some expert will write about it. And also there are other things that are also dependent on why we actually use, or there are other reasons why we use output capacitors. It has to do something with what's it called, bias current voltage. So sort of if you have a voltage swinging from between +5 and +6, then you are supposedly to remove that +5 and only get something that swings between -0.5 to +0.5 volt. But maybe you also have to have something going to ground. Then I'm not sure about this stuff because I'm not an electrical engineer, believe it or not. Believe it or not. And yes, we are going to need another thing right here. It's called a power connector. I mean, we need some way to get the voltage to go in through this circuit. So either we could put a battery right there and put it in a box called a little noise box. You can use a lunch box, you can build a little wooden box, or you can take whatever, a cookie jar. And there you go. But I will use a something called a panel instead of a cookie jar, and the panel is then placed in a box called a eurorack box, I think. I'm not exactly sure about the terminology here. But anyways, this box is having something called a power supply, and this power supply has something called, I'm not sure, power connector maybe. So you can use the same power for a lot of different things called modules. And modules are like, if you imagine a noise box to be a box with 6 sides, just like dice, I have 6 sides, and the eurorack module is a box with 1 side only. So you see right here, it's a box with 1 side only, and the other side is shared over the collective of the eurorack. And the thing I wanted to get to with this is that then you have connectors looking like this, and you have cables looking like this, and you just connect them. So when you build something new or bought a new module, you just put like this, bam, and you get electricity, and it starts to shine if you have diodes in it. So there you go. So I will try to use some of these power headers and put them here. But first I need to make sure that everything is ready. So the things that are not ready is that there's supposed to be some capacitor here. One there and one there. So what I will do is start with putting the smallest in there, and then we will try with that, and if it doesn't work, then I will also add the slightly larger ones. So, and if you put capacitors in parallel, it is, you just add the values together. So if you have 2 nanos like I have here and 150 nanos, then you get 152 nanos. So it's the opposite way around like resistors, if you know how to calculate resistor values in parallel and in series. If you put something in the same holes, then you are putting parallel. If you're putting something like a chain where each individual component is a link in the chain, then that is what is called serial connection. And if I'm boring you with this very basic knowledge, make sure to remember that this channel is for everybody of all races and sexual preferences and so on, and also different ages, different levels of knowledge, and so on. Because there's a problem, as I often find, that oftentimes tutorials are either too simple or too hard. So therefore I try to sort of be both very, very easy and also very, very hard, so that it can give something to everyone, you know, something for everyone. It's like I am the Santa Claus of analog electronics. So, have you been a nice child? In my country we say, hello, hello, or Santa Claus says, hello, hello. Are there any nice children here? And all the children are going to say, yes, I've been so good all year. I've been eating my spinach. No, they just say, shut the fuck up, Santa. We don't believe in you. Give us our presents or we will beat you up severely. Because, you know, we're a real hard society, tough and hard society. So let's see if we have any hot glue in the hot glue gun, because this is really sliding around here. Alright, so remember not to burn yourself, because hot glue is hot, and I mean real hot. and it's also not just hot, it's also sticky. And that means that it will stick to your body and keep burning you until it's cold again, which might take a while, and that will give you some severe burns, as I learned in a recent video. So, can you see what we are missing now? It's only one thing, and it starts with a G. G or J? I'm not so good at English alphabet language and alphabet names. So what's the name of different alphabet signs? Yes, A, B, C, G, E, F, J, J, K, L, M, P, Q, S, T. Yes, that was a real good song. Did you invent it yourself, or did you just find it on internet? No, I find it in my memory, because my memory is going so far back in time. I'm almost like Cher, you know, like, if I could turn back time, I would definitely not do that, because every other child was so evil to me, and they beat me severely. Oh, look. They would spit on me and call me names, so won't you know, that was real fucked up. I hate my childhood, it was real fucking fucked up. Yes, I accidentally changed song there, I'm sorry about that, shouldn't have done. So I can't find any drill bits, so I'm using a Phillips screwdriver. Because, you know, quick and dirty means that it's quick and it's dirty. And dirty means that you use tools for reasons they're not supposed to be used for. There you go, you learned something new today. Alright, breathe. Sometimes when I do these videos, I forget to breathe because, you know, it's so fun talking. Why breathe when you can speak? You know? Am I right, people? Am I right? Look, I'm accidentally scraping here, but that's an aesthetic choice that I'm making to make it look real ugly. So. Okay, the hole is too small, so what do? Well, I don't know. Well, you just take anything that is a little bit larger than the hole and just sort of expand the hole's diameter. Do you see that? I'm just sort of like, I was just severely encouraging the hole to become a little bigger. I didn't have to use any brute force. I just looked at it and I said, please hole. Please hole. You have one and only one purpose of your life, and that is to open up, to let a what's it called, to go in. Well, it's called an RCA jack, you stupid motherfucker. Did you hear? I could rhyme. By the way, does anyone know if my channel will be banned from YouTube for swearing? Anyway, that would be really, really, really nice if you would write that in the comments fields below, because I can't help myself from swearing, you know, it's part of my cultural inheritance. It's like a social act. It has to do with the specific place in space and specific class, which is the working class. And my home, let's call it county or state, is called the valleys. And in the valleys, everyone speaks using a lot of bad language. It's just the way we speak. It's a social act. So, you see what I see now? Well, if you don't see it, I sure see it. And that is, we only have the power connector to go. And just because I can, and because I'm so poor, I'm only using half of the power connector because I'm out of the full set, so to speak. And that means 5x1 pins. I mean, it's still the same. I mean, why do you have to have double? because in the eurorack cable we have 6 cables for ground, we have 2 for positive voltage and 2 for negative voltage. This module only uses positive voltage and ground, so we could choose between using 8 wires or just 2, or as I am doing now, using 4. And these 4s are 3 ground wires. Why 3 ground wires, you might ask? And I cannot answer you because I was not the one who invented eurorack. I have no idea. I mean, these decisions were made above my head. Even though you might think that I invented eurorack, I'm actually only an amateur hobbyist. Even though you know that I'm really professional and I'm gonna start my own brand and a shop, I know, so you can shop my stuff, you know. You want to sort of, hello, dear Nerding and Hoarding, please send me the A-stable multi-vibrator fully built, or in a kit, you know, or partial kit, or, you know, like that. And then you think like, wow, Nerding and Hoarding is just like Corey and all of the others synthesizers like Moog that has been around for, you know, like since forever, you know, since time before time. It's like archaic. But then I have to disappoint you and say, unfortunately, that is not the case. Oh no, I fucked up. I fucked up slightly. The slightly fuck up means that I forgot to connect the ground to the yeah, but wait a minute, I have an idea. We can do like this. So yes, the ground to the jack. You see, all electricity is in relation. There's nothing called 5 volts alone. I mean, 5 volts means nothing. It's just the potential. It's like meters over the ocean, or whatever it's called in English. It's only in relation to something else that something can have a voltage, and this something else is called ground. So if you have a voltage, you have to compare it to something to make it actually do something. It's like if you have a really big rock, you also have to have a ground beside it in order for something to fall down from it. Just like Newton, you know about Newton? He was sitting under a tree of apples and he was thinking about the planets, and then the apple fell to his head. And he thought like, oh, that was just like the moon, and it fell down on me. But the moon is also falling down on me, but it is constantly missing me. It just passes right through, and then it just bends a little bit, and then it falls again on me, and just slightly beside me it falls all the time. So there you go, Newtonian physics for you, 101, just for free. What should I charge for this? You know, because you know YouTube, it is a commercial platform, you know. I mean, I am a content producer. I'm producing content that is like so good. It's like something for everyone, but it's also super good for super nerds, because you know why? Super nerds will eventually get a problem with their mental health, and guess what? I have severe mental health problems that I will also talk about in this channel, and also in relation to nerding hobbies, you know. So there you go. It is okay. So the glue is now in a temperature that I like to call very hot, and that is a bit annoying because it takes so long time until it gets cold enough to be hard. And as we all know, hot glue needs to be hard in order for the shit that we are trying to glue down to stay in position. Alright, so If you're building this yourself, you can also do like this, that you actually build a capacitor bank for each of these. And a capacitor bank is just, it's very simple. The design of it, it's very simple. It's just like this. You have a ground here, and you have a lot of switches like this, and then you have a capacitor here, and that goes to ground, and you have another switch, and then you can have any amount of this, and then you change the value very quickly. And what you do is, so this is your other connector that goes to, and this doesn't even have to go to ground. It can go to another point, any node inside of your circuit. And then you will have maybe one that is always on. And then if this is 1, this is 10, this is 100, this is 1000, then you could, or also you can count in binary, might be better. So if you have 2 here, you can have 4, 8, and 16, and then you can get sort of any value. And you can just go on here, put more and more on here, and then you can sort of have the possibility to switch in any value. And if you do this in both positions in this circuit right here, both here and here, then you get something that could work in a very large range of frequencies. And you can also get really fucked up behavior if you make it really asymmetrical. If you say you have a 1 nano here and you have a 680 nano here, or even 100 micro, which is 100,000 nanos. But now we will test this little thing just with 2 of these, 2 nano, and 12 volts, and yeah, let's see if it can make any noise and what kind of noise it can make. So first thing first, amplifier. Make sure when you test a new circuit that you have no idea how loud the signal will be, that you turn down the volume almost to nothing. Then plug in your voltage. Remember that red wire on this cable means negative 12 volts. So always make sure that the red is not connected to the red on this one. Very counterintuitive, but there you go. And I turn it around, and there we go, like that. Then I turn up the volume. Will we hear anything? Unfortunately, there is nothing to hear. So what does that mean? Well, it could be one of 2 things. Either we have a supersonic sound, meaning we can't hear it, maybe bats can hear it, and the other could be that there is no oscillation going on. So you could test with an oscilloscope, or you could just test with sort of manually pushing 2 larger capacitors against the existing capacitors like this. Are we getting any noise at all? Well, I sure can't hear anything. Are you sure that this circuit is supposed to work? Yes, I built it 1000 times. Well, no, not exactly. So, because I don't want to bore you too much, we will do like this right here, that I will select the same circuit very quickly on the computer, and we'll see what frequency we will get. So start up a computer that has a application called FileStat. I don't know how to say that because I don't know if it's Polish or German or Dutch or whatever. Might even be French. So let's just look right here, because I don't want to edit any video. That's why I do this. Otherwise, I would of course do screen recording. But you know, I don't have time for all of that stuff that other people find so interesting to edit video, because I don't do much of that in my youth. So let's just quickly just borrow a multi-vibrator and save some time right here. So multi-vibrator A-stable, and this value is like this value is like this, and this value is a little bit critical because we don't actually know what it is, but we can sort of guess that it is somewhere like 1 mega. Let's just go with 1 mega for now. And are you seeing this? Yes, and this is standing 2 nanos, and this also 2 nanos, and we are having another 2 nano right here, and we're checking the output right here. And I'm just gonna do a new scope right here and try to see if we can see frequency. Yes, we are seeing the frequency right there, and it is, let's see, delete scope, no, delete scope, yes. So could we please see a frequency here? It is a very, as you see, the wave is quite interestingly fucked up here. If you look closely, you can see it's sort of, but it's in the audio range, I would say. Let's just see what it says. It's supposed to count, but it's not super good at it when it's just fucked up a wave. But please work. Couldn't we see anything? Alright, so if you are with me now, I will hopefully see something. Could you please work just for now, just for this little time right here? No, it doesn't want to do it. Okay, maybe if I do like this, maybe it will work to count. Please work. What the motherfucking shabada. Oh, I'm sorry, I didn't say that. YouTube, don't ban my channel just for speaking out. Okay. I mean, please, how hard can it be? How hard can it be? I'm just saying. So I just do a little bit thinking right here, and guess what? So I actually saw something there. Maybe if I do like this, can I please get a reading on the fucking frequency? How hard can it be? I mean, it's like right here, you see? Show frequency. How hard can it be? Show RMC. I have no idea what that means. I don't know what that means. Show the duty cycle. I don't know what that means. Well, I do know what that means actually, but please show me the frequency. How hard can it be? So, okay, so if I do it like this, if I would add my 150 nanos there and actually 152 nanos there, but you know who is counting? What kind of frequency what would we get then? I mean, would we even get any kind of frequency? That is what I would like to know. It seems like no. Seems like no. And this is if we would sort of shine a light on it. Wow, do you see? We're getting something here that looks quite like... Please count the frequency. Okay, it's sort of 200 or 400. But this is highly depending on this. So if I shine a real bright light on it, it would become like this. And that's too high to count, apparently. Yes. Yes, yes, yes. So anyway, what I have learned now is that I will try to add the 150ers, if you know what I mean. 150ers. Okay. I'll just solder them right there, and yeah, we'll see if that will lead to anything. So just stay with this channel, don't change the channel, because as you know, we are doing quick and dirty magic. Oh man, that sounded a little bit creepy, didn't it? Because dirty, it can also sort of refer to sexual stuff, don't you? Dirty talking. Did you hear that? I heard something that sounded like a frequency. But who am I to say? I'm biased in this manner because I am the builder. Okay, so this is really not the way you're supposed to do soldering. I know that. You're definitely not supposed to solder in a live circuit, and you're most definitely supposed to attach things before you solder and all of that. But you know, quick and dirty means doing everything wrong and hopefully get something to work. Now I'm only removing this because I need more space. Yes, and here's the second 150er. Okay. So I did remove the electricity, but I didn't remove the output wire, so there is where the noise is coming from. So soon you will listen to, yes, that's the sound of 50 hertz for you. We have 50 hertz in my country. There you go. And now just cut off if you have very long leads somewhere. If you don't have that, you don't have to care about anything. Okay, be prepared for loud noise or anything that doesn't sound at all. So I'm now shining a light very closely to it. Nothing happens. Right, that is really severely boring to hear. Okay, so what do we do? What do we do when life is giving you the middle finger? What do you do? Well, why don't we sniff in the circuit, as I usually call it? Wow, that's cool sound, isn't it? Let's poke around, see if you find something that sounds cool. Unfortunately, if you're gonna do this right, you need to have this connected to ground, so I will sort of ground this through my finger. Unfortunately, that didn't work. Okay, so this shit is not working at all. So guess what? You are on the channel called Failing and Nerding and Hoarding. And I'm your host, Mr. Magoo. There is of course the possibility that I put this in the wrong way. So let's double check that. Let's help me with this because I'm not so good at this. So please write in the comment fields below how to do this. What I'm trying to see here is that the leg number 3 collector is pointing upwards on both of my transistors, and that would mean that it would be looking sort of like this. CE. Okay, Is it looking like that? Well, that one looks like that, and that one looks like that as well. So, another thing that might be a problem is that we might have a very, very large resistance. I mean 20 mega resistance in these resistors. So maybe, I'm just saying maybe, if we would add an 11th part called a little trim pot, just to test out, you know, test out things. How about if we would just test to put a little thing right there? I mean, it would not be part of the official circuits collection, 10 or less, of course, but you know, we are not a dictatorship. We are Improv 101. So, how the fuck is you one going to do things like this? Alright, I am not irritated. I am just very irritated. Why can I never get anything to work? No. It is not fun. It is boring as hell, you know? Hell. You know about hell? It is a place on earth. They say heaven is a place on earth, but I say no, hell is a place on earth. I tell you, it is. So what the fuck is going on here? I'm sorry, YouTube, don't ban my account just because I said a bad word. Ah, there you go. I didn't have any electricity on. So now, cover your ears. I will turn down the volume. So there you go. Remember to always double check the things that you are not even considering being a problem. Because on Nerding and Hoarding we do every kind of mistake, such as putting no electricity into a circuit. But now I will test turning up the volume on the output amplifier. You hear that? It sounds almost too good to be true. And now we have the possibility to do like this. What? This is actually confusing for me, because look now it's a loud signal, right? I mean a loud frequency. No, I mean now it's a high pitch. And as I add I do shadowing of it, and then the pitch goes down, and then when I shadow it more, it goes down very far, and then it starts to scream crazily. What is that? Yeah, that is a very strange behavior, I would say. So, anyway, if we were to, so just for the sake of testing, I'm not saying you should do this, because this would include an 11th component right here, and we have already bent the rules a little bit. Yeah, if anyone knows about this behavior, please let me know, because I don't understand anything. Yeah, okay, so where are we at? Yes, we have created something that sounds horrible.